Myself, Prayag Patel, working as an assistant professor in IT/ICT department of LJ Institute of Engineering and Technology. In today's video lecture, I will discuss about the Huffman code. Huffman code used for find the encoding. We can use the for encoding purpose. We can use the Huffman code. Now, first problem definition of the Huffman code. Huffman invented a greedy algorithm that for find the optimal solution. Means we can say that the optimal prefix code is called the Huffman code. Huffman coding is a lossless data compression technique. Means you can compress the data without any loss. In Huffman coding, assign numerical code for each character. For example, given data in form of character A, B, C, D like this, and you can find the code as a numerical code. Means for example, consider for character A, code like 110, for character B, code like 010 like this. So here we use Huffman coding for this purpose. There are mainly two major parts in Huffman coding. First one is build a Huffman tree from the input characters. Means you can construct one tree for the given data or given characters. Second step is traverse the Huffman tree and assign the code to characters. Means after generating a tree, you can consider the one by one character and find the Huffman code for each and every character. So here given data in form of frequency or some like set of characters. Now consider the two method or two algorithms for Huffman coding purpose. Now first one is considered as a fixed length Huffman coding and second one considered as a variable length Huffman coding. So you can understand one by one. First one is considered the fixed length coding. In fixed length coding, how we can find the Huffman code using fixed length encoding method. If we use fixed length coding, we will need fixed number of bits to represent any character. Means in fixed length coding, each and every character code length is same. So here consider, for example, consider code for character A equal to 101, code for character B equal to 010, code for character C equal to 110. Means we can say that for A, B and C, three character, there are same number of digits for each and every character representation of numerical number. So here consider three digit number for A, B and C. It's called the fixed length encoding. In variable length encoding, we can consider A as a length 1, B as a length 2, C as a length 1, 2, 3 like this. So in this case, each and every character have a same length, then consider as a fixed length encoding. If the each and every code have not same length, then consider the variable length encoding. Now consider the one example for understanding the fixed length Huffman code. For example, find the Huffman codes for following characters. Here the given characters like character A, B, C, D, E and F. And frequency of character is for first character A, frequency equal to 45, second character B, frequency equal to 13, third character C, frequency equal to 12, D frequency equal to 16, E frequency equal to 9 and F frequency equal to 5. So here consider the given data in form of frequency. Here frequency of A equal to 45 means in given string 45 times A character is repeated. B 13 means B character repeated 13 times like this. So in some case given data in form of frequency or in some case given data in form of string. So if the given data in form of string, then first you find the frequency of the each and every character. So here consider the frequency table. Now step number 1. Step 1 is arrange the character in the ascending order of their frequency. So here consider the minimum frequency as a first position. So here consider this frequency table and consider one by one frequency from lowest number to highest number. So here consider initially F equal to 5 as a first. Second one consider E9. Third consider C12. Fourth B13. Then D16 and last consider A45. So this order consider as a ascending order of frequency. Now consider the next step, step number 2. In step number 2, combine the two nodes with minimum frequency. So here consider the total 6 character A, B, C, D, E, F. So here consider the pairing of two nodes, but pairing is done in order of their frequency, means in ascending order of frequency. So create a new internal node with frequency equal to the sum of the two nodes frequency. For example, here in ascending order, first is F5, then E9, then C12, then B13, then D16 and last A45. Now pairing of two elements. So first two element consider as a F5 and E9. Combine these two elements and consider the new node, internal node, and value of the internal node consider as a addition of frequency of first node and frequency of second node. So here consider F5 plus E9. So here consider 5 plus 9 equal to 14. Now for the next two node, combine the next two node. Next two node means C12 and B13, combine these two node. And final result is addition of these two nodes, consider frequency equal to 25. So consider the new internal node as a 25. Now third step is remaining two elements are there, D16 and A45. Now combine these two elements D16 and A45. Addition of 16 and 45 consider as a 61. So third internal node consider as a 61. Now after that, next step, step number 3 consider as a rearrange this sequence, means new node. Here consider the 3 as a new node, 14, 25 and 61. Arrange these 3 node into ascending order, means rearrange the tree in ascending order and assign the 0 to left branch and 1 to right branch. So here consider already 14, 25 and 61 in ascending order. No need to change this order. Now assign the 0 value to left child and assign the 1 value to right child. So here consider the F5, consider the link as a 0 and E9 consider the link as a 1. In 25 consider the C12 as a 0 and B13 as a 1. B16 as a 0 and A45 as a 1. So for each and every node in a tree, left child consider the 0 and right branch consider the 1. So here consider the next step, step number 4. Combine two nodes with the minimum frequency, means already we combined first step. Now after that we have a 3 node, 14, 25 and 61. Now for these 3 node, consider the two node combination. Means here first consider the first two node as a 14 and 25. So combine first two node 14 and 25 and total equal to 39. So consider the new internal node as a 39 and two child as a 14 and 25. Means create a new node 39 with the addition of two frequency 14 and 25. Now consider the next step, rearrange the node or tree into the ascending orders and assign the 0 to left branch and 1 to right branch. So here consider 14 as a left child of 39. So consider 0 value at the left child and 1 value at the right child, means 25 link consider as a 1. Now after that combine the two subtree, means here consider the two subtree as a 39 is a one part and 61 as a second part. But here we want to represent the number in a same length code, means fixed length code. So here for fixed length coding, each and every node or leaf node in same level. So here consider last node 61, only one node are there in our previous case. Here we see that 39 is one node and 61 is second node. So in 61 is at lower layer and 39 is upper layer. So for combining these two nodes, first we match the level. So for matching the level, here we consider 61 as a one node. So another node consider as a 0 node. So 0 plus 61 combination consider as a 61. So here we consider first pair is 14, 25 and total is 39, and in second part consider 61 as a one node and 0 consider as a second node. For addition of 0 and 61, total equal to 61. So first we put 0 then 61 because 0 is less than 61. So consider the next step as a, here consider the 61 at second layer, and in 61 left child is not represented because 0 consider as a left child and right part consider as a 61 as it is. So here intermediate node 61 is added because we want to arrange the data or find the code in same length. So here consider the 61 as an intermediate node. Now consider the next layer, combine the two nodes 39 and 61. For combining these two nodes, consider the total equal to addition of these two frequencies 39 plus 61 equal to 100. So here consider the 100 as a root node. Now consider the left child of 100 as a 39 and assign the code to 0, and right child of the 100 consider as a 61 and assign the code equal to 1. After that we want to find the code for each and every node. So here consider this step number 7 as a final table for the Huffman coding tree. Here consider the traverse the Huffman tree and assign the code to character. Now consider the given character or frequency is like this: A45, B13, C12, D16, E9 and F5. Now last line consider as a Huffman code for each and every character. So here this is a fixed length encoding, means here each and every character have a same length of code. Now if you want to find the code for character A, then how we can find? Here consider the root node as an initial node. From the root node you consider your node, means if you want to find the code for character A, then start the moving from root node to your character A, means here consider first 100 to you want to move at the A45, then consider first one, then second one, then third one, means here consider the character A Huffman coding equal to 111. Now consider the code for B. Code for B, here consider first move from 100 to 39, then 39 to 25, then 25 to B13. So here consider the code from top to bottom, means root to your node, root node to B node. So here consider 0, 1, 1 as a code for B. Now consider the character C character from 100 to 39, 39 to 25 and 25 to 12. So code for that is 0, 1, 0. Code for character D, consider the D at right side of 100, then right side of 61, then left side of 61. So here consider code as a 110. Now code for character E code equal to 001. Code for character F equal to 000. So this is considered as a Huffman code using the fixed length Huffman coding. Now consider the another method. We have a two algorithm. First one is fixed length coding and second one is a variable length coding. We already discussed the fixed length coding algorithm. Now consider the second algorithm is a variable length coding. For find the optimal code, we use the variable length coding, not a fixed length coding. Now consider the problem definition of the variable length coding. For find the optimal solution, use the variable length codes to input character. Means here consider the optimal solution. For find the optimal solution, you can use the variable length coding. Next step, consider as a length of the assigned code are based on the frequency of corresponding characters. Means in previous case we consider the each and every character have a same length of code, but in variable length coding which character are repeated, mostly repeated, means frequency of which character frequency is high is considered as a minimum length code. So your code is depend on your frequency. Which character is less repeated, then code length equal to high, and which character are mostly repeated or frequently repeated, then length of this code considered as a minimum length. The most frequency character gets the smallest code and least frequently character gets the largest code. The variable length code assigned to input character are prefix code. Now what is the prefix code? In prefix code, the correct codes are assigned in such a way that the code assigned to one character is not a prefix of code assigned to any other character. So for example, consider here a equal to 01 and b equal to 010. Then here consider the given data or given code like 01010. So in this case, here consider first two character as a 01 in both a and b. So here consider 01 as a not prefix code. So consider C code as a 11. Here consider these three as a not a prefix code. This is how Huffman coding makes sure that there is no ambiguity when decoding the generated bit stream. So that's why your code in form of not ambiguity in any code. Now consider the same example for variable length Huffman coding. Now in fixed length Huffman coding, you combine two nodes which are possible and combine this node and add this frequency for find the intermediate node. Now in variable length Huffman coding, consider the given character like A, B, C, D, E, F. Frequency are here. Now consider the step 1. Arrange the character in ascending order of their frequency. So here already we arranged in our previous example. First minimum frequency consider as a F5. Then next frequency consider as a E9. Then next frequency consider as a C12. Then B13. Then D16. Then A45. So this order consider as a ascending order of their frequency. Now after that, here we consider the first two node only. Not combine two nodes. First we consider only first two nodes. So here consider the step number 2. Extract two nodes from the minimum frequency. Means here consider the minimum frequency first as a 5 and second one E9. So here consider the first two frequency as a 5 and 9. Create a new internal node which frequency equal to the sum of the two nodes frequency. So here consider the new node or internal node as a 14 and 14 consider as a addition of two frequency 5 and 9. Now make the first extracted node as its left side and the other extracted node as its right side. So here consider F as a first or left side and E consider as a right side. Now after that consider this tree and assign or rearrange the node. Here initially consider the assign 0 to left branch and 1 to right branch. So here in 14 consider F5 as a 0 because F5 as a left side and E9 as a 1. Now after that rearrange the tree in ascending order. So here consider the remaining node, consider like 14 is the first node, then 12, then 13, then 16, then 45. So here consider the remaining all node and arrange this remaining all node with the new node 14 in ascending order. So initially consider first as a 12, then 13, then 14 as a new node, then 16, then 45. So here lower figure consider as a ascending order of the your frequency. So after that consider the next step. In next step consider the extract two nodes with minimum frequency. So here consider the ascending order like 12, 13, 14, 16, 45. Out of this all consider the minimum two frequency only. So here minimum two frequency as a C12 and B13. Now combine these two nodes and find the new node as a addition of these two frequency. So consider the 12 and 13 addition of these two consider as a 25. Now consider the assign the value 0 and 1 to this node means 25 left child consider as a 0 and right child consider as a 1. Now consider the rearrange of this node. Now consider the step number 4. Rearrange the tree in ascending order. So here consider first 14, then 16, then 25 as a new node, then 45. So this is considered as a ascending order. After that consider the next step as a combining first two nodes. So in step number 5 extract the two node with minimum frequency. So here consider the previous sequence as a 14, 16, 25 and 45. Now here consider first two frequency as a 14 and 16. Combine these two frequency means addition of these two consider as a 30. So 30 consider as a new node or internal node. Now after that consider assign the left child as a 0 value and right child as a 1 value. So 14 consider as a 0 and 16 consider as a 1 value or 1 branch. So after that, rearrange this data into the ascending order. So here consider in previous step, first is 30, second is 25 and third is 45. Now arrange this data in ascending order. So first consider as a 25, then consider next as a 30, then next consider as a 45. Now after rearranging this data, repeatedly you can combine the first two node only. So here first two node consider as a 25 and 30. So here combine these two node, means we can say that addition of these two node as a 25 plus 30 equal to 55. And after combining these two node, first left child assign the value 0 and right child assign the value 1. After that, rearrange this data, means first you can consider the 45, then you can consider the 55. So after rearranging, combine these two nodes. So next step consider as a combining of these two nodes, and combining of these two nodes total equal to 100. First 45 and next is 55. Now value assigned to left child as a 0, means A code consider as a 0 and 55 consider as a 1 part. So here consider this tree as a final tree for the Huffman code using the variable length. Now if you want to find the Huffman coding for the given character, then you can consider this tree as a final tree. Now second step is find the code for each and every character from the given tree. So here move in the tree from top to your node and find the Huffman code. So here consider first character A. Now consider the code for character A. Starting from the root node means 100 and move to your node A. So here consider the left child of 100 as a. So code for the character A equal to 0. Only one digit code 0. Now code for the character B. B at right side of the 25. So consider the code for B 13 from the root node 100. So first move from 100 to 55. Then 55 to 25, then 25 to 30. So here consider code as a 1, 0, 1 for the character B. Now code for the character C equal to 1, 0, 0. Code for the character D consider as a 1, 1, 1. And code for the character E consider as a 1, 1, 0, 1. And last character F. For the character F, consider the code from root node 100 to your node F. So move from root to your node F. 1, 1, 0, 0. So this code considered as a Huffman code using the variable length Huffman code. So here consider the variable length, means we can simply say that this code as an optimal code, because which character are repeated most frequently is size considered as a minimum length code. So here consider 0 as a minimum length code. So here consider A repeated 45 times, so code only one character code 0. Then B repeated 13 times, then code consider as a 3 character. For example, E consider as a 9 times or F consider as a 5 times, then code consider as a 4 digit code. So frequency of the code is minimum, then code length is high. Then frequency of the code or character is maximum, then code length equal to minimum. So total number of bits required to store the data is minimum according to variable length, because in fixed length, for example, consider the for store the any bit, consider the any character A. For store the character A, require the 3 bit. For character B, require the 3 bit. For character C, require the 3 bit. For character F, require the 3 bit in fixed length, because each and every character has a same length 3. So frequency consider as a total frequency as a 100. 100 multiply 3 consider as a total number of bit required to store the data. Means 300 consider as a total number of bit required to store the data. Now in variable length encoding, consider the total number of bit required, like for character A, consider the 45 times repeated, means frequency equal to 45. 45 multiply 1, because 1 length for the code 45 means A. So here consider the 45 multiply 1, then 13 multiply 3, plus 12 multiply 3, plus 16 multiply 3, plus 9 multiply 4, plus 5 multiply 4. So this code is minimum than the fixed length. So that's why we can say that this code is optimal code. Now consider the algorithm for the variable length Huffman code. Here consider the initial step of your example. First is F5 and second one is E9. F5 consider as a left child and left child consider as a X and right child consider as a Y. For understanding the algorithm, first remember this point. X as a left child and Y as a right child. Now addition of frequency, first X and Y consider as a root node Z. So here consider Z equal to 14 means addition of these two. Now consider the one by one step of the algorithm. First, name of the algorithm, Huffman code. C consider as a your argument means given data or given frequency consider, for example, A, B, C, D, E, F. Then consider 6 different characters are there. So consider C equal to 6 different characters. Now n equal to mod C means n equal to how many number of characters are there. Frequency are given. So here consider 6 frequency are given. So n equal to 6. Now consider the next step, Q equal to C. Now what is Q? Q means 1 Q for arrange data of frequency. But here consider the Q equal to C means consider the arrange of your frequency means first F5 then E9 like this means one ascending order of your data consider as a Q. Now consider the next step for I equal to 1 to n minus 1. Here consider the n minus 1. What is the value of n? N equal to 6 because total 6 different characters are there. Now n minus 1 here consider or write the n minus 1 because how many number of merge operation are done for 6 different character? We can say that the total 5 addition or 5 merge operation. So here consider loop, I loop from 1 to 5 only. Now consider the for loop. First is allocate a new node Z means consider the new node as a root node or internal node as a Z. Now Z dot left consider as a X equal to extract minimum Q. So here consider Z dot left means here consider Z14 as a root node, left consider as a X and X means extract minimum Q. Here extract minimum Q is a function which can extract the minimum value out of the all value means out of the all element in a Q. So here consider the minimum value as a F5. Now consider the Z dot right equal to Y equal to extract minimum Q. Means first we extract the minimum as a F5. Now next minimum value as a E9. So extract the E9 from the Q and consider the Y element and Y consider as a right child of the Z means consider as a root node. Now Z dot frequency equal to X dot frequency plus Y dot frequency. Now X dot frequency means 5. Y dot frequency means 9. So addition of these two consider as a frequency of Z. So here consider the frequency of Z equal to 40. Now next step is insert QZ. Here consider the insert operation for the inserting new node in a Q because already we have a 6 element F, Y, A, B, C, D like this in a Q, but we combine F and E and new node consider as a Z. So insert the Z node into the your Q. So consider this step insert QZ means in Q insert Z element. Now last step is return extract minimum Q. This is your final step of the algorithm means you extracted data in your answer. So consider the return extract minimum Q as a root node. So this algorithm used for the Huffman coding using variable length. Now in today's video lecture we discuss about the fixed length encoding, then variable length encoding, then consider the Huffman code algorithm for the variable length. How you can find the best code using your variable length Huffman coding. Thank you for watching.